In this video, I will take you step by step into solving exercises that require making capital budgeting decisions using the internal rate of return and the modified internal rate of return. You will learn the definition of the internal rate of return, IRR, how to solve internal rate of return exercises using the financial calculator, the advantages and disadvantages of the internal rate of return. You will also learn the definition of the modified internal rate of return, MIRR, how to solve modified internal rate of return exercises using equations, and the advantages and disadvantages of the modified internal rate of return. So let's get started by defining the internal rate of return. It is a capital budgeting decision model defined as the discount rate that produces a zero net present value. In other words, it is the specific discount rate at which the present value of the costs or the cash outflows equals the present value of the benefits, the cash inflows. The criteria for making decisions or capital budgeting decisions when using the internal rate of return is that we accept projects when the internal rate of return is greater than the required rate of return, which is also known as the hurdle rate, and we reject projects when the internal rate of return is less than the required rate of return. Now let's move to how to calculate the internal rate of return. As we said earlier, the internal rate of return is the interest rate that results in a zero net present value. Here is the equation of the net present value, as I assume you're familiar with. Just in case you're not familiar with it, you can always go to my video on the net present value. So here is how to calculate for the internal rate of return. I will have the net present value at 0 and then the cash flows. The cash inflows are discounted by a rate. The rate that makes the net present value 0 is our internal rate of return. How we solve it using this equation is by substituting the interest rate. So each and every time I will try to use an interest rate until I try to find the net present value at 0, which is really difficult if you're going to do it manually. However, most times we use the financial calculator or the spreadsheet. And in this video, I will show you how to answer or how to find the internal rate of return using the financial calculator, which is really simple. So here is an exercise. It says Flynn Incorporation is considering a 4-year project that has an initial after-tax outlay of $80,000. The future after-tax cash inflows from its project for years 1, 2, 3, and 4 are $40,000, $40,000, $30,000, and $30,000 respectively. Flynn uses the internal rate of return method to evaluate the project. What is the approximate internal rate of return for this project? Now, before we start, I want you to pay attention to one thing. The question does not ask you whether to accept or reject the project. It simply asks you what is the internal rate of return or the approximate internal rate of return. So let's answer this using the financial calculator. I am using here a Casio financial calculator. So press cash key and then you will find a menu. In the menu where it says I, skip it for now and then move to cash where it says cash equals D editor and then %. Press the execute. You will find X and the frequency. So we will enter the values in X. We will enter the cash outflows and cash inflows as follows. So start with minus 80,000 because that's the cash outflow, and then execute, and then 40,000, execute, 40,000, execute, 30,000, execute, and 30,000, execute. And now we will press the cash button again to go back to the menu and then go using the arrow all the way to IRR. IRR is the internal rate of return. Now press solve. It will take a few seconds to get the answer because the calculator is making the calculations. And then it will give you 28.88. So your internal rate of return is 28.88%. It's very simple using the financial calculator. Now, a few things that I want you to pay attention to. Number one is when solving for the internal rate of return, you are trying to get the net present value to zero or as close to zero as possible, especially if you're doing the trial and error method. Now, if you're using the trial and error method, which is doing it manually, when you get a net present value which is greater than zero, you might want to try to adjust the interest rate that you're using and increase it. Now, bear in mind that the interest rate here is the discount rate. So if you increase it, you will get a less net present value. So again, if your net present value is less than zero, so you got a negative number, try decreasing the interest rate that you're using. So this will make it easier for you if you're doing the trial and error method, which I don't really recommend. Okay, again, just a reminder, when making a capital budgeting decision, we will accept projects if the internal rate of return is greater than the hurdle rate, and we will reject projects if the internal rate of return is less than the hurdle rate. Now, speaking about the advantages and disadvantages of the internal rate of return, it is consistent with the time value of money. It is a rate and not a dollar amount. But then it has a few disadvantages. It is time consuming without a calculator or a spreadsheet. The potential for more than one internal rate of return solution when cash flow is non-standard. What we mean by non-standard is that we have a number of cash outflow. So it's not one cash outflow at the beginning and then the remaining are all cash inflows. And in this case, we might have more than one internal rate of return, causing us problem making a decision. And then the internal rate of return assumes that all cash flows can be reinvested at the project's internal rate of return. This is a major setback for the internal rate of return. Another one is having the potential for errors in ranking projects. And finally, can lead to incorrect selection when there are two mutually exclusive projects. Now, looking at all these disadvantages, you might wonder, why do people still use the internal rate of return? Well, in fact, it is the second most commonly used capital budgeting decision model after the net present value. To overcome the disadvantages of the internal rate of return, we can use the modified internal rate of return. So let's see, what does it mean? It is a modified version of the internal rate of return model to overcome its main weakness of assuming that all cash flows of a project are reinvested at the internal rate of return over the remaining life of the project. Thus, the modified internal rate of return model is based on having cash inflows reinvested at the company's cost of capital. Now, a decision criteria is accepting projects when the modified internal rate of return is greater than the required rate of return, also known as the hurdle rate, and reject projects when the modified internal rate of return is less than the required rate of return. Let's look at the equation of the modified internal rate of return. It is the future value divided by the present value raised to the power of 1 divided by n minus 1, where the future value, we mean the future value of all the cash inflows, and the present value is the present value of all the cash outflows, or the costs. Here's another version of the very same equation, so you can choose or use whatever you feel more comfortable with. Now let's look at an example. It says Corbett and Sullivan Enterprises use the modified internal rate of return when evaluating projects. CSE's cost of capital is 9.5%. What is the modified internal rate of return of a project if the initial costs are $10,200,000 and the project lasts 7 years, with each year producing the same after-tax cash inflows of $1,900,000. So this is a simple exercise where we have to find the modified internal rate of return. We can simply use the equation of the modified internal rate of return. But to take you step by step into solving it, I believe we should first find the future value of the cash inflows. Looking at the example here, the cash inflows is the 1,900,000, but this is like the same amount each year for 7 years. So this sounds like an annuity. So we have to find the future value of an annuity. And here is the equation of the future value annuity. And we will simply plug in the numbers. And we will find the future value of an annuity at 17,751,032.13. Step 2 would be finding the present value of the cash outflow, or the cost. The cost here we have is $10,200,000, and we only have this cash outflow, so we will try to find its present value. Here is the equation of the present value, and we will substitute, raising the interest to the power of 0, because it's already now. So we will get the answer at 10,200,000. The last step will be finding the modified internal rate of return simply by using the equation and substituting the numbers. And we will find it at 0.0824 or 8.24%. Now let's look at an exercise where we have more than one cash outflow. It says here, Galaxy Computers Incorporation is considering a 5-year project with the following cash inflows/outflows. Knowing that the company's cost of capital is 10%, what is the modified internal rate of return? As you can see, we have a cash outflow of 11,000, and then we have from year 1 until year 4 cash inflows of 7,500, and in year 5 we have another cash outflow of 20,000. Now whenever you see a minus figure, you directly understand that it is a cash outflow. We will solve this problem using the equation of the modified internal rate of return. But before we do so, let's find the present value of the cash outflows. As you know, we have two cash outflows, the 11,000 and the 20,000. So we will use the present value equation to find their present value and get the summation of both of them, which will turn out to be 23,418.426. The second step would be finding the future value of the cash inflows. We have 4 cash inflows, all of them are 7,500, so we will use the future value equation to find their value. And we will find it at 38,288.25. And now we can simply plug in the numbers into the modified internal rate of returns equation, like so. And we will get our modified internal rate of return at 0.1033 or 10.33%. Now the final part of this video is about the advantages and disadvantages of the modified internal rate of return. It is actually consistent with the time value of money. It is a rate and not a dollar amount, and it corrects for most of the problems of the internal rate of return and gives the solution in terms of returns. However, it is time consuming without a calculator or a spreadsheet, and it has the potential for multiple internal rate of returns. Thank you very much for watching this video. I hope you find it very useful. If you have any questions or comments, you might want to leave them in the comments below.